Good morning, good afternoon, good evening, wherever you are in the world, and welcome to another session on day 2 of the A4Q Congress second edition. My name is Debbie Archer, and I'm delighted to have with me Lovelesh Beeharry, who's the founder and president of the Mauritian Software Testing Qualifications Board, an ISTQB trainer, public speaker, an automation engineer, entrepreneur, and technology enthusiast. And Lovelesh is going to be talking about Selenium Grid. I'm going to pass over to him now, and Lovelesh, looking forward to hearing your presentation. Quick one for the audience: if you do have any questions, please do pop it in the comments box, because Lovelesh will answer questions at the end. And I know that he's really keen that you do ask him anything that you'd like to know. So over to you, Lovelesh.
Thank you, Debbie. Thank you for the introduction. So I believe we can get started. It's a pleasure to be here for the second edition of the A4Q World Congress. And I would like to thank you all for joining this conference, for joining my talk, which will be centered around the Selenium Grid in a keyword-driven automation framework. So let's get started with some background about me, a little introduction. So my name is Lovelesh Beeharry. I'm a lead software test engineer in automation and non-functional test at Ikera Indian Ocean. I have cumulatively around 11 years of experience in the software quality industry. And I've been working for different companies across my career. I'm experienced in manual automation, performance, and now I'm learning as well on security testing. And I'm the founder and the current president of MSTQB. In my spare time, I'm also an ISTQB trainer and a conference speaker. So what are we going to talk about today? So obviously there will be some flavors of Selenium. So we'll have a small introduction about Selenium, the different products in terms of automation solution that Selenium is proposing to the market. We'll just have a brief introduction as well on what is a keyword-driven automation framework. We'll have some overview about Selenium Grid and how we can implement Selenium Grid onto a keyword automation framework. And also we'll finish with the gains of the grid. So what are the advantages of implementing the Selenium Grid? So without further ado, let's get into the subject. So about Selenium. Selenium is quite popular on the market. It has been there for around the last 17 years. It's still open source. It's free. The source code is available on Selenium Dev. Recently, a few weeks back, I think it was 2 weeks back actually, Selenium 4.0 was released. So that's the latest stable version for Selenium. There are many automation frameworks that are proposing solution based on Selenium engine. So for example, we have the Cucumber framework, which is using the Selenium engine behind to do automation solutions. And Selenium automation is suited for web application, web apps, web portals, and so on. And it is very much popular because it is um, uh, programmable. It is actually supporting different programming languages such as Java, C Sharp, Ruby, JavaScript, and Python. So that was about Selenium. And now we dive into the flavors of Selenium. So Selenium automation solution comes in three distinct products. So the first one is Selenium ID, which actually provide a solution for the record and playback, uh, which is basically to create some repetitive test with some basic framework in place where you could record a certain action and then play it multiple times over again. It's a quick gain. Selenium ID provides a quick gain to the business. But if you'd like to have further tests, some more flexibility, some more robust test, and also some more scalability in terms of testing, then you would like to move to Selenium WebDriver. So in this Selenium WebDriver, you can build your own framework. It can be page pattern, it can be um, uh, keyword driven, it can be also data driven. So you would then use Selenium WebDriver to build those frameworks. And the last one is a Selenium Grid, which allow the parallelism of test execution across different machines. So the essence over here is actually to run multiple test cases, multiple test suites concurrently on different machines. So a quick introduction about the keyword-driven automation framework. So the essence over here, the basic concept is to have the actions that you would like to perform as automation, to have the locators and the test data all externalized in a certain text file. It can be a text file, it can be an Excel file, or it can be even an XML file. So we have all these information outside the framework, and the framework itself, like this function over here, is just reading the Excel file and then carry out those actions on the browser. So the essence of having a keyword-driven framework is to the externalization purpose, and the advantages of doing that is to get even non-technical uh, people to write test cases. They don't need to know programming, but they are still able to help in automation. So this is a keyword driven automation. Why it's keyword driven? Because it's the action that is driving the test. So over here we're having like action for enter text. So the enter text will be executed in the case statement. Then we'll have the click action and so on. So it's the action, the keyword action is driving the tests. We've implemented the framework, keyword-driven framework as well at IKEA, Indian Ocean. This is a snapshot of our framework. So we have a test suite. The test suite is a collection of test cases that are sequenced, and then we can select different parameters of the test, like on which browser you would like to run the test, whether you want to take a screenshot in case of there is a failure, whether you want to record those videos in case there are failure, and if you would like to re-execute the test suite if there is any failure detected in that test case, in that test suite, I mean. And also in the same Excel, we have another worksheet, which is test cases, in which all the test cases, the test steps are arranged. So they will be executed serially one after the other. So that was about keyword-driven framework. So if you would like to learn more about keyword-driven framework, I've done a talk in the first conference for A4Q, and it's available on YouTube. You can scan this QR code or use this tiny URL to access the material. Or you could just simply search it on YouTube. You will get the video. All right. So let's dive into the core of the subject, Selenium Grid. So with Selenium Grid, the the basic concept of having Selenium Grid is to sustain the parallelism of test execution. So we are able to execute tests concurrently on different machines. And by doing that, it means that the WebDriver is actually sending commands to the host machine, which is the client machine, which will be executing those tests on different nodes. Those are those machines that are actually executing those tests and on remote web browsers. So parallelism of test through WebDriver script that is channeled to the client machine. And then we have a centralized, we have the concept of centralized control as well in Selenium Grid, where all the code, the framework, the test script are on a single machine. And from that machine, you are able to control the execution on all the other machines that are connected to the grid. And another advantage is the scalability. So we are able to plug in more machines, more nodes to the network to have more capability of execution. And we are also able to remove it. So it's dynamic. If you have more tests to execute, you will need more machine. If you want those tests to be executed in less time, so you need to plug in more machine. So the solution that Selenium Grid is proposing is quite scalable. And we have the cross-platform capability. So what I mean by that is on the grid itself, we can have machines that are executing tests that are having different operating system. They can be Linux, they can be Mac OS, they can be Windows. They can also be virtual machine, not necessarily physical machine. And there is also the ability of the Selenium grid to have an inherent mechanism for load balancing. So they are able to actually channel those requests to machines that are free and so on. So there is an inherent capability of Selenium Grid to do load balancing as well. So this is an example about how a grid could be set up. We can have 5 nodes. They can be physical machine, they can be virtual machine that is connected to a hub, which is the central machine that is sending the automation requests to each node. And all nodes are actually different in terms of operating system. They can be using the latest version of Firefox. They can be using a specific version of Chrome. They can be launching test on Edge and so on. So those are the architecture in terms of a hub and node for Selenium Grid. Now, we need to follow a certain step-by-step um, view, a certain step-by-step mechanism to actually implement grid on a keyword-driven automation framework. So the first best practice is to have test cases which are independent. What I do mean by that is test cases are not like the failure of one test case will cause a ripple failure on other test case that follows. So we have to break those dependencies in terms of test cases and make them as independent as possible. From time to time, actually achieving 100% test case independence may be complicated. For example, even at IKEA, we are testing platforms that uh, test cases are applicable only after login. So there is one level of dependency. So the concept over here is to have test cases as independent possible according to the product that you're testing. So breaking out down those dependencies is very important. Then we have test suite. Now a test suite is a collection of test case. So if we are having multiple test suites to be executed, we have to make sure that those test suite can be executed independently. Let's take, for example, I have a free test suite. So if there is a test suite, like let's say test suite 2, that need to be executed only when test suite 1 is completed, we have a high level of dependence over here. The aim over here is to cut down those dependencies so that those tests could eventually be executed concurrently without any um, ripple effect in terms of failure, or without any even precedence that this test set or test suite need to be executed first, then second, and third. So the second step would be to cut down in terms of test suite dependencies. Then the third one is actually to implement a certain fail soft strategy. So what I mean by that is a recovery mechanism. So let's say there is a test case that is failing, a test case for creating a certain entity on a platform is failing. And next to it, we have a test case which is actually modifying those created entities. So the concept over here is to have those test cases as independent as possible, and also to have a recovery mechanism. So if test case one, which is creating the entity, is failing, if we don't have a fail soft strategy, the second test case, which is trying to modify that entity, would be failing as well. So how can we implement a recovery mechanism over here? In our framework, we've implemented a conditional step. Okay, we also implemented some step that allow our framework to do some query on the database and so on. So if the second test case is executed and it doesn't find the created entity that was done in the previous test case, it will do a query on the database, pull up the correct information, and then modify those entities. So there will be a failure in the first test case, but that failure doesn't cause a ripple effect in the next subsequent tests. So we are still able to test modification of that entity, and the failure is localized in the creation test and not the modification. So this is what I mean by fail soft strategy. So there are many ways of implementing those kind of recovery mechanism. The first one is the conditional step. So a certain action will be carried out if, let's say, a locator is found on a web page, or if there is, let's say, pop-up is appearing on the web page, and that pop-up is not part of the test. So there is active scanning behind in the framework. In those conditional step, they will check whether those pop-up are there. If they are present on the page, if they are present on the page, they can close it, and they can also move forward with the next test. So a certain level of fail soft strategy is important in a keyword driven framework if we would like to implement a parallel framework. So the next one would be parallel test suite execution. Now the concept over here is, once we have the test cases independence, we have the test suite independence, we have a certain mechanism to recover from failures, then we would try to run those test suites in parallel. So we'll have those implemented in terms of threads. Each thread will have a certain test suite assigned to it. They will run it. So let's say, again, I have free test suite. I would like to run it in parallel. So free browser will be opening. Let's say one is on Chrome, one is on Firefox, and the other one is on Edge. So these free browser will be running on my local machine. So it's still one machine, but running multiple test suite concurrently. Then once this is achieved, the task is quite easy then to implement the grid, because then we just need to assign each thread to a certain machine, and they will take over the execution on their local resources. So the grid in this case as well, they are able to reduce the load that normally parallel test suite execution would impose. If I'm running test, let's say my personal laptop is able to just sustain 4 browser, I need to run 8 test suite, then I will need to just select 4 for the first run, then 4 again for the next run. So I have to break the test in two in any case, because I'm running it on parallel suite, but on a local machine, on only one machine. But with grid, that limitation is removed, because now we have a collection of machine. We have a machine cluster itself over which the test suite can be distributed. So the last step would be concurrent parallel execution on more than one machine. So parallelism, I've made a small architecture diagram just to explain that bit. So this is about the parallel execution. So we have a main thread. The main thread will be reading the Excel script. In our case, it is the Excel file. So they are taking Excel script and they are reading it. The framework is reading it. It's pulling all the information. It's actually pushing all the information towards the machine memory. And the test initializer is reading from that memory to know which tests need to be executed, which test parameters are selected, for example, which browser need to be executed, and so on. So in this case, we have free threads that are created because we have free thread test suite. Let's take, for instance, free test suite. So the framework will create free threads. Each thread will have their own WebDriver initializer. It means they will have their own mechanism to talk with the browser that is executing on the thread, and they will start the test execution. Once the test execution is complete, they will do inherent reporting as well. In our case, reporting may be sending an email with all the steps that pass and fail, and so on. So each thread would handle their initialization, the execution, the reporting, and once this is done, they will tear down as well. Tear down is actually just wrapping up the test, closing the browser, um, and merging with the main thread again to reach the test completion on the main thread. So the architecture is broken into two: the main thread that will read, that will do all the initialization part, and then we have the multi-threaded architecture that will actually be channeling those tests on individual thread, and each one will handle their own execution sequence. So this is the parallel test suite architecture. Now, moving from parallel to the grid. So the first thing is to actually launch the hub. So this is the central machine that will listen to all the node requests that are attempting to register on the grid. Then the second step would be the machines are registered, the nodes are registered. So in this registration process, the machine that is trying to register on the hub will be giving his IP address. The node will be giving to the hub their IP address, and the hub will be assigning a certain port number to the node for them to know that they will be sending commands. The hub will be sending command to the node on that port. So the node will be listening on that port from the hub, and the port will be the door actually for which communication will happen. Okay, so once this is done, the next one is this is a step that we've implemented in our framework, which is IP polling. This is direct consequence of the pandemic situation actually, because initially we didn't need to have IP polling because everyone was in office. In our framework, we are running tests on our team members' machine. So everyone is having a laptop or a PC. So we'll be using those local resources to run tests. When everyone was in office, that was not an issue because the IP that we were getting from the hub was the office IP. Everyone was at the same network. But once we were struck by the pandemic situation, we had to work from home. There were some people in office, there were some people from home, and we had a mixture of IP. So we had to find a way actually to um, um, to just order all those IP, to just put a certain order, a certain cleanup that mechanism to have those IP corrected and the port number as well corrected. So The IP pooling is a feature that we implemented in our framework. We'll go in more detail in subsequent slide about IP pooling. Once this is done, we have the IPs, we have the port numbers cleaned. The next one would be the launching of the test. So the WebDriver are instantiated for each thread running on each machine, and they will have the reporting. They will have their uh, teardown as well within the thread itself. So the architecture now becomes like this. We have the test scripts, we have the Excel reader, which is still reading from the test script and putting all the details on the machine repository. And then we have the test initializer, which are using those details and communicating now with the hub. The hub is already registered with all the nodes. Actually, the hub is already having all the nodes, all the machine clusters connected to it. And the hub will channel commands to those nodes to execute tests. So you will notice over here that this node, the node number one, has two threads. Okay, so we can implement a parallel architecture on top of the grid architecture as well. This is what we've done as well in our framework. We've implemented parallel architecture on top of grid. What it means is I can run multiple threads on one machine. So it's not a one-to-one relation. We can have multiple threads on one node. We've tried this actually on the local machine that I'm using. I've tried it with 32 threads. We were able to run 32 test suite in parallel on one machine. We can choose the platform as well to be headless, so that it doesn't use much resources. So a headless browser is actually a browser that doesn't have any UI. So the front end rendering part of the um, of the process for testing is not done. Everything is tested in memory. We just have all the action to be executed, the platform as well, and the browser as well, in memory of the machine without anything on the UI, and we execute the test. So running test in headless mode um, is more actually memory efficient. It's not using all the memories that the machine has. So the hub will communicate with the node. The node will create their threads, and each thread will again have their WebDriver initializer, the test execution, the reporting, and the teardown. Once this is completed, they will merge with the main thread for test completion. So the only change over here is the inclusion of the grid layer between the main thread and the running and the multi-threaded architecture. Now, in the IP pooling and port mapping, so we had this issue where a node, maybe someone was from working from home, someone was in office, someone was working from home connected on a LAN cable, someone was from home on Wi-Fi, home Wi-Fi, but everyone was connected on VPN. So we wanted to use those machines as well to do the tests, to do those parallel tests on each machine. Problem was the node was registering with the hub on different IP. We were getting either the home Ethernet IP, we were getting the Wi-Fi IP, and we couldn't use those IP to communicate with the nodes. So we needed a mechanism actually to just clean those IP and clean the port number, match the IP and the port number. And this is what I mean by IP pooling. The test initializer does that for us. So the concept here is the test initializer doesn't trust the IP given by the hub. So the hub is writing all the IP, all the port number on a log. The test initializer is reading that, and he's trying to just make sense of those IPs and the nodes of the nodes and the port number that are available in the log from the map that we've created. So we've created an IP map in our test script. We have the user, so the person actually owning the laptop. Then we have the PC name, laptop name or PC name. We have the VPN IP, we have the office IP, and we have a degree of parallelism. So these information are actually channeled towards the test initializer, and they will try to map the IP and the port number that the hub give with the map that we have over here. So that can make sense. Okay, so if a PC is giving me the local IP, I will neglect that. I will use the IP that I have on my map, and then they will be able to communicate. They will be able to launch the tests. And the degree of parallelism over here is actually each machine have a certain memory, has a certain memory and a certain capability in terms of processor. So we will try to limit not to exceed the that amount that the machine can sustain, the node can sustain. Let's say on node 1 I can run only 3, so at most 3 test suite in parallel will be assigned to that node. In another node I may be running 4, so at most 4 would be assigned to um, to that node. So the way it's done, the algorithm actually behind to do these degree of parallelism is to go through one pass of test suite. We check if there is still some test suite to be executed that are not assigned to any node. We'll go through another pass. So it's a round robin algorithm that we are going through again and again until we complete all the test suite that need to be executed. So this is the concept of IP pooling. We've implemented that bit on our framework and not on the hub over here. Right. So this brings me to the gains of the grid. So the first one is obviously the time saving. Given that we are able to run tests in parallel, we save a lot of time. So just for an example, we had scripted around 13 to 17 hours of tests on one of the product that we are testing, and we were able to give a report before parallel framework implementation. After 2 days, we get the request. Let's say on Monday morning, we get a request to run the full regression set on a certain platform. It will take it will take us 2 days actually to complete the test, analyze the report, and then prepare the report and send it to the developers, to the QA team as well. So there was quite some lag in terms of getting the request and supplying the report. This is our motivation actually to move forward with Grid and the parallel framework. Now we are able to cut down the execution time by 70%. So the test that initially took 2 days to run, we are now able to sustain those execution in half a day. So we get the request in the morning, at noon, we are able to send the report. So it's a 70 to 75% of saving in terms of time. The next advantage is the centralized aspect of Grid. So initially, when we wanted to run tests in parallel, we had to manually copy the automation framework code. We have to copy the script and put it on different machine and then manually launch it on each machine. Problem with that is we had multiple copies of the framework. We had multiple copies of the script. Let's say someone is getting a failure and he's supposed to do a certain maintenance. He will do it on his machine on the script that he has. Someone else is doing the same on another machine. And then now harmonizing those changes together, merging those changes together on a single script was quite tricky. Was quite tricky because we most of the time actually will lose track of which changes are merged, which one are not merged, and so on. So with Grid, we don't have this issue. We have only one script, which is uh, given to the hub machine, and it's the hub that is distributing those test suites. So the centralized test script is helping us a lot. The next, the next one is actually we are able to leverage on our test to perform some kind of load testing as well. So with one machine, I've tried with 32 users on headless, concurrent virtual users. So those each thread will be one user. So on my machine, I was able to sustain 32. Let's say we have 10 machines like that connected to the grid, and we would be able then to inject around 300 virtual users, concurrent virtual users on the platform. And the advantage of using the grid to do a bit of load testing would be the instant gain we get in terms of scripting. So we already scripted regression tests. We are able to constitute a test suite only for load testing from those regression tests. So there is no duplication of rewriting tests in another load test framework and so on. We get an instant benefit of having on leveraging those tests for load testing on the grid. So that's an advantage. And the last one is actually the efficient use of our machines. So the machines that we have in office and at home, they are not being used 24/7. So most of the time the machine are idle. They have CPU time. They're not using all the memory. So we could launch tests remotely in headless mode so that the person can work as well at the same time while the tests are being carried out in the background. So it's a more efficient use of our resources, our hardware resources in this case. So those are the gains. And I would like to end this presentation with some lessons learned. actually going through this journey of implementing Selenium Grid across our automation framework, which is Q1 driven. We've gone through some challenges. We've learned a few things as well. I would like to share those experiences with you. So the first one that I've learned is small step do matters. Do matter in the sense that if we had the big bang approach, we wanted to implement the Selenium Grid upfront. Maybe the project would have been a failure. I've read quite some research paper about those implementation in some industry, and they implemented the Big Bang approach because they had a tight deadline. They wanted to do the test as soon as possible on different machines and so on. So the architecture, the design that they came forward with, were not suited for a long term um, gain over the project. So that's why I'm saying over here that small steps do matter, because we did it small, step by step. We implemented a framework first. We got the instant benefit of having at least a framework. We are able to run automated tests. We evolved the framework um, in chunks, bits and pieces, and then we were able to implement the grid after doing the parallel framework. So doing it by small, chunk by chunk, is something that did help us. Failing is part of the process. So we went through quite of some failure. We have to understand that this project, these kind of project are very much intensive in terms of programming, in terms of technology. We are using different library. So we implemented some library that was there, and it was working for some product, but not for the other, because our framework is actually centralized. We have only one framework. We are running those tests on the framework for different product. We have 7 to 8 products that we have already automated, and we are running those tests on those products. So we did change the framework to make it suitable for another feature in the product, but it was failing on the other side. So architectural change and failure in the Selenium grid implementation, it's part of the process. But you learn from those failure and you improve on top of that. Then we build on top of a working solution. So the IP pooling was something that we wanted to implement within the grid itself. We downloaded the source code for the grid. We checked whether we could have the IP pooling done within the grid. Fortunately, we didn't move with that solution, because if we would have moved with that solution, we would have been in a perpetual mode of maintenance. What do I mean by that is there are updates that are being done on the grid as well. So a few weeks back, we had Selenium 4.0. So if we change the code on the grid, with those updates, we'll have to maintain those test cases. We'll have to maintain those code again within the framework that we've modified. So the solution over here was to have the working solution, the grid, have it there, build on top of the grid. So we had the polling on top of grid. So that was something that we've learned when we try to implement the polling in the grid itself. And sometimes there are a few things that we are not able to solve. So we've created quite some Stack Overflow threads. Even on the Selenium community, we have some threads over which we got some help. So the Selenium community is very strong. We have dedicated people who are actually trying to solve others' problems. So the expert um, help here was very important for us. And the last one would be the brainstorming session. So discussing our design, because our framework is being used across multiple product for automation. So discussing our design is very important. So have everyone in the room, which is specialized in different products, which are running the test on different product, and propose a design change, propose an improvement in the solution, do a proof of concept, show it again, discuss over it, and and embellish that solution. So those brainstorming session actually helped us a lot to build the framework that we have right now. So that was it. Um, if you have any questions, I would be glad to answer it. I'm here to clarify any confusion that you may have. Right. So, Debbie.
Thank you, Lovelesh. Two things to say thank you for. Fantastic animations. I love that. Secondly, that was really useful from a tutorial point of view. So
Yes.
I'd encourage people to perhaps come back to this and look at the recordings, because it was really full of really practical, good advice and showing people how to, which is really good. So thank you. And the lessons learned as well, important to share that, so much appreciated. Let's give you a few questions.
Sure.
What are the drawbacks of using Selenium Grid as a load test framework?
All right. So, okay. So this is an interesting question. So we do have solution. We do have solution that are present on the market for dedicated load testing. For example, we have JMeter, we have WebLoad, we have Load Runner. So those framework are for load testing, but we are using Selenium Grid to do some load tests as well. So the drawback over here is we are doing the load test from a front end perspective. So the browser opening, or if it is headless, it is still there is a browser in the memory, like Chromium is still running in the memory. So those tests are being done in the memory. It is still on a front end level. Okay, and those tools like WebLoad, Load Runner, JMeter, they can do load tests on a backend level. So this is where actually we need to be careful when we are doing load tests. We need to ensure that we are giving the appropriate level of detail as in the report, to make sure that we are talking about front end load test, not back end load test. Also, something to really consider over here, because in the report we get only the response based on the machine. So if a machine is quite weak in terms of memory, in terms of processing capability, so if we try to push, like, let's say 10 browser on that machine, and it's not able to sustain, so the response time will be quite high. And there is a quite an inherent part of that response time would be because the machine is weak. So it's not really the server or a performance issue on the platform. It might also be with the machine. So there is the requirement of having machines which are powerful. There is also the requirement of having the knowledge of how many browsers I can push onto the grid, so that you are not impacted by those machines limitation.
Thank you.
Yeah.
What was the need that you had to move to the Selenium Grid?
Okay, so the first one was actually that the cut down in terms of time. We were missing out windows for run. Let's say we had to provide a report within the day, but given that the tests were quite extensive, were quite intensive in terms of nature, they were quite time consuming as well to be run on automation level. So that was the first pulling factor that was grid, that was parallelism. That's one. And the other one was also to make an effective use of our resources. So we have the virtual machines, we have powerful laptops, powerful PCs already in our infrastructure. Just connect all these, and to get the benefit, the upfront benefit of having grid in place. So those would be the pulling factor for me to Selenium Grid. Yeah.
Thank you. Matthias, I was going to say, can you just share the comment from Martin? He says, wow, excellent framework explanation. I'm looking forward to the code and tech details to implement it. So please, where can I follow you? For sure, I'll write.
All right. So
LinkedIn, I guess.
yes. So my LinkedIn handle is on the screen. You can see on the footer of the of the slide. So you can connect with me on LinkedIn. You can also connect with MSTQB on Facebook. So you can just scan this QR code. You will get our Facebook page. You can connect with us. We do write technical newsletters as well. Those designs, those codes actually would be part of subsequent newsletters that we will write. So if you subscribe to our Facebook page, you will be in the loop of communication.
That's wonderful. That's wonderful. What a lovely
And
shout
I
out.
do have quite some question when I do ISTQB training, or even conferences. Where is Mauritius located? So it's just next to Madagascar. So I've just put a little arrow over here so that you can locate Mauritius on the world map.
I think a lot of us are keeping an eye on where that is. Just to go back to your
Yes.
experiences, how much effort was invested to implement the Selenium Grid framework on the keyword-driven framework?
All right. So if we see the whole picture of having the framework in place in Ikera, it took around 2 years to get it where it is right now. But we implemented the first version of the framework within a month or two. We had a working version. We continuously embellished on that framework to make it into a Selenium grid automation framework. So just moving from the traditional keyword driven framework onto a parallel framework, that required some massive architectural change. There were variables that we needed to handle because those variables are required to be accessible to each thread. There were some variables that need to be encapsulated within the thread itself. So those changes, those architectural changes, it took us around 2 weeks to get a good design, and an additional 1.5 week actually just implemented into parallel. Then moving to grid, it took us another week actually to put it in the grid layer in the design. Yeah.
Thank you. And which programming language did you develop the framework on?
So the framework is developed on Java.
Mhm.
We use a development framework called Maven, so it helps us to manage our dependencies in a more proficient way. Because we don't want to have external files like jar file external libraries in our framework code. Like you have to refer to those files through relative or even absolute path, and that will limit our framework on running on different machines. So we used Java and also Maven to develop the framework, and so far all the dependencies are being managed on Maven repository, and it's been working well so far. Yeah.
Perfect. Um, what are the advantages of implementing Selenium Grid on a keyword-driven framework instead of a page pattern framework?
Okay, so a page pattern framework would mean that the codes or the locators, the test data, all the information that we need to run those tests are inside the code itself. So you need to be technical to run those tests. But in a page pattern in a keyword driven framework, anyone can help. So we have a QA team. Not everyone in the team are actually quite at ease with writing codes, with updating codes as well. So they are able to help with automation tests. They are able to help with writing tests that would be executed on the grid framework. Even they don't have the knowledge of programming. So it's just filling the Excel. And even the Excel, why we use Excel? Because we have inherent validation that we can do. We can have drop down list. We can have, so all the actions that we've coded in the framework are actually appearing on a drop down list in the Excel,
Okay.
and the testers are just able to select those actions and put in their locators. So we just need to train actually those those person actually just to take out locators, how to take out XPath, how to take out uh, an element by the ID. So this training need to be given. Once they have it, they are ready to automate,
That's
to write
perfect.
automate test cases. Yeah.
Martin's saying thank you for the link and for the info about Selenium 4 release. And you've got a lot of shout outs here from Atish and lots of clapping. And I don't know the name of the person, but their handle is Nebulous83 saying well done. So fantastic. I think we've come to the end of the session, Lovelesh. There are no more questions in the comments at the moment. So a huge thank you to you. As I say,
My
that was
pleasure.
really, really good. And as Martin said, a great tutorial actually, and excellent content. It's been my pleasure. Thank you to everybody who's actually tuned in, and please stay with us. There are some more sessions coming up which I'm sure are going to be just as excellent. My thanks yet again, Lovelesh, and see you
My
soon.
pleasure. Thank you.
Oh, bear with me. Martin's got one last question. Let's just do it quickly. Let's just do
Sure.
it. I'm going to steal a moment. How about versions? The grid runs okay on XP Win 8, Win 10.
Well, I've tried on Windows Server. Our hub is on Windows Server, and we've connected with Windows 10. So support for Windows XP is now over. So we're not considering on running Grid on those machines. But on Windows 8, it's supported. It is supported. We don't know about subsequent versions of Grid. So there will be upgrades actually to Grid 4.0. There will be more changes. So um, supporting of Windows 8 is still conditional. We don't know that yet. but it is working as of now on Windows Server, on Windows 10, on VM, having Windows 8 as well. It's supported with 4.0. It's supported there. Yeah.
That's smashing. Martin, I hope that answered your question. I'm glad we were able to fit that one in. Again, thank you to everybody, and special thank you to Lovelesh. Take good care all.
Thank you.
Bye.
Bye. Stay safe.